So, first of all, we have to decide when we have another test. And we've got to have another test soon. We're going to have three. If we're going to take three tests and then a final, we have to have another test rather soon. So, my proposal would be to have a test on Monday of next week. Is anybody opposed to Monday of next week? Test two? That would be, today is the 24th, 25th, 24th. Today's the 23rd, so it'd be the 30th. Monday. And tentatively, it would be 8 questions. A 4 would be from chapter 9, which would be basically solving the from Laplace back to time domain. Okay, so that would be the separation of variables, that type of thing. So it would be Laplace.
I can't see it.
You can't read that. Okay, we'll get there. We'll get there. There you go. Laplace back to time domain. In other words, separation of variables. And that would be 4 questions on that, and then 4 questions from chapter 10, or really from these 50 questions that we have here, which would be basically doing the whole thing. Starting with a circuit and then going from there. So we will get a little bit further this week. I think we're on 26 or 27, I'm not sure. 20s. We're up to the one with the I remember that. And we'll work on those, and then where we get on Wednesday, that'll be the end of where the testing will be. We won't go any further than that. So I'll pick 4. They won't be exactly the same, but they will be similar. So I think we ended up with, we were at 24, right? This is the one we were at. Okay. So we'll work through a few more of these. We'll get through maybe the 20s, maybe into the 30s. We're not going to get the whole thing done, but we'll eventually get most of them done. And the test 3 will be a review of the first ones, and then a few more in the second ones, or the end of the higher ones. So we'll see how this goes. Well, these tests are not easy, but we'll see how it goes, okay? We can always go back and regroup. How's that? We can always go back and do a test again. If everybody bombs out, we can just do another test or whatever. That's my plan. So anyway, number 24. So this is a circuit with current 6 U of T amps, and then we've got 3 ohms. We've got 1 Henry. We've got 0.5 farads. Okay, so we've got this circuit right here. I need to get my cheat sheet like everybody else. I need it because I usually can pretty much remember everything from scratch, but I make sure. So anyway, it's my crutch as well as everybody else's. You need this sheet in order to be able to navigate. So we'll keep the same process. Oh, I know where it's at. I hid it in my book. So anyway, a little disorganized, but that's all right. It's Monday. I just got through a 7-hour trip. never put your, I shouldn't say never or always, but it's really tough putting a parent or somebody in a nursing facility. Um, get an education all of our own about it. Some of them are good, some of them aren't so good, and they don't have to be very good in order to survive in this environment today. Okay, so let's go ahead and do this. So now this is 6. Okay, and this, if you were to look at this, you were to say, now, what would I do with something like this? Well, the best thing to do is to, you have two choices. You can, this could be recognized as a Norton. You can convert it to Thevenin. Or I can convert these three to a combined resistance. So this is the 1/1 rule. Okay? This is messy. This isn't quite as bad. Okay? So I choose the not messy approach. But if you've got 3, now if you got 2, it's R1, R2 over R1 plus R2, not quite as bad. But if you have 3, you get to the 1/1 rule, and with S's and the denominators and all that kind of stuff, that gets, we'll work through that approach, but it really is not your friend, okay? Does everybody agree with that or not? Do you see what I'm saying? When you got 1/1 rule and then 1 over something over S and this, and you got to combine all these, it gets really cumbersome. Or would you rather, take a vote, would you rather do the Norton to Thevenin, or would you rather do the 1/1 rule? Huh? Which one? The Norton to Thevenin, yeah. So if you do the Norton to Thevenin, what do you get? You get a voltage supply here that is 6 times 3 or 18, okay? V equals I times R, and there's R and there's I. So this is V equals I times R. That's all it is. So it's 18, all right? And then you bring your 3 up here. Now you're asked, now what is it asked? Okay, so find voltage across, this voltage here is the same voltage as the voltage here. Okay? So what is this? This is 1. There's S. And this would be 2 over S. So what's the parallel combination of this? It is R1, R2 over R1 plus R2. So it's S times 2 over S, R1, R2 over S plus 2 over S. Now that's my resistance here. So what is my I? Or what is my, it says find voltage. So now we have to decide what we're going to do with this. We've got to, this is the resistance of this part. So it's S times 2 over S, R1 times R2 or R1 plus R2. So these S's cancel out. So it's 2 over S squared plus 2. And then you put your S in the numerator. So basically S squared plus 2 over 2S. So you put the S in the numerator. So this is S. So now we can now look at this and say, okay, now the resistance of this part is this, the whole thing is this, and then let's just voltage divider is our best friend. So basically it's this resistance over this resistance plus 3 times 18. So it's voltage across over here is equal to 2S over S squared plus 2 times, excuse me, S squared, S2 over S plus 2 times 18 over 2S over S squared plus 2 plus 3. Now we've got to work on this, and I'm going to have to take a picture of that, redo it. Okay, so this is so far. So now we're gonna start again. Okay, so we're gonna regroup here. So this is so here's our circuit. 18 volts, and it's 18 over S. I forgot that part. We got to do that. Every once in a while I forget that. And 3 up here, and then 1 S here, and then then 2 over S here. Okay, so my voltage supply is 18 over S times this resistance here is 2S over S squared plus 2. So it's this resistance, 18 over S times 2S over S squared plus 2 over 2S over S squared plus 2 plus 3. Everybody agree with that? That's voltage divider, and that works. Any problems so far? Now we just got to get this. This is bad, but it isn't as bad as the other approach. Okay, so this gets you to a point now where we can start combining things. So what do you got to do first? Well, you got to, by the way, when I first started out, we said we're going to have our second test is next Monday, March 30th, right? Okay. So anyway, an announcement. 3 times what? S squared plus 2 over S squared plus 2. So now you combine these two and you say basically, everybody agree with that? That's what you got to do. And these S's cancel out. So it's 18 times 2 or 36 over S squared plus 2 in the numerator. Now in the denominator, it's an S squared plus 2 in the denominator, and the S squared plus 2 is going to cancel out S squared plus 2. But in the numerator, it's going to be 3S squared plus 2S plus 6. Everybody see that? Now this is going to cancel with this. So our final result is going to be 36 over 3S squared plus 2S plus 6. Now, we've got to get rid of this number. Well, we don't have to, but you know, it's nicer if we get rid of the 3, right? So this is 12. This is S squared plus 2/3 S plus 2. So now we go to war with 12 over S squared plus 2S over 3 plus 2. Now, what do you do with that? It's messy, but you can do it. Okay, so what do you do? Well, quadratic equation is your best friend. Okay, what is the quadratic equation? S equal minus B plus or minus square root of B squared minus 4AC all over 2A. Right? A is 1. So it's equal to minus 2/3 plus or minus square root of 2/3 squared minus 4A times C or times that. So this is definitely going to be an imaginary number. It's all over 2. So it's equal to 1/3 plus or minus 4/9 minus 8 all over 2. So we take that, put it in our calculator. 4 divided by 9 plus, minus 8 equal minus 7.55. So this underneath here is square root of minus 7.55 divided by 2. So the square root of 7.55 is what, Ted? .747. It's 1/3 plus or minus 2.74 divided by 2. And there's an I in that. .37. So it's 1/3 plus or minus 1.37 I. Everybody agree with that? So now we come over here and we say, okay, how do you find the final answer? Well, it's 12 over S minus 1/3. You put a minus in third, minus 1/3 plus 1.37 I times S minus 1/3 minus 1.37 I. All right, and there's nothing wrong with this. It's just now that you can now what do you got to do? Well, you have two choices. I think the one choice is basically at this point in time to just use this to convert to Rule 19. This is equal to S plus 1/3 quantity squared plus 2.74. Okay, which is 1.37 squared. Okay, so it's equal to this. And at this point in time, you don't have to go through all the other gyrations. All you got to do is you got to say basically, this is Rule 19. Everybody see that? What is the answer? It's 12 e to the minus 1/3 t sine of 1.37 t. And you're done. Any questions? You don't have to go through this part of it if you don't want to. You can just immediately convert it to this and then use Rule 12. Any questions about that one? Well, that gets you, when do you have to do the K and all that kind of stuff? If there's something else plus the K, you have to do the K and the K star. But with this one, you do not have to, because that's all there is left. That's all there is to this. Any questions about this one? Everybody's giving me a blank stare like, huh? Do you believe this, or do you see what I did? You don't have to do the K and the K star with this one. You can go straight. I started to go down that path, but then I said, nope, all I got to do is use Rule 19 and I'm done. Okay, now, remember that, remember this answer. Okay, I'm gonna take a picture of this answer because I certainly am not a, you know, this is the way you work this, but this is one way of working it. Now, the other way of working it is what? Taking it at face value at the very beginning. So I'm going to make this as big as I possibly can. All right. No, I could have. Anyway, let's go back and let's look at it again. So let's look at number 24 the other way. 24, and here is I, and it's 6 amps. 6 U of T is 6 amps. This is 3. Oops. Three and 1 and 0.5, right? 0.5 farads. So this is, I guess I should have done it in red because that's what I was doing the other day in red. So this is S, this is 6 over S point, as this is 2 over S, and it's just a straight old 3. Okay, so with this approach, we're going to use the 1 over 1 over rule. So what is the voltage? Voltage is equal to I times R. And if we have the resistance of all three of these, we've got the R. Okay, so what is it? It's 1 over 1 over rule. So it's 1 over, because we have 3 of them. If we had 2, R1, R2 over R1 plus R2, and you're done. Now this is 1 over 1 over 3 plus 1 over S plus 1 over 2 over S. Or really, it's the S over 2. And I can immediately do that right there. It's S plus S over 2, okay? Now, what do I have to do here? Maybe it isn't, maybe this isn't so bad. It looked bad, but it may not be so bad. So it's what? We get a common denominator. So what's our common denominator? Well, 6s looks like the common denominator, doesn't it? So it looks like 1 over 2 over 6, 2 over 6, and then with 2s over 6s plus 1 over s, which would be, okay, 6 over 6s plus s squared times 3 over 6s. Isn't that right? So I have this 1 over s, excuse me, 1 over 3, Ted, plus 1 over s plus s over 2. Have to get a common denominator. So what's the common denominator? 6s. So this is, you gotta get it, whatever it takes to get 6s. So it's 2s over 6s, multiply the numerator and denominator by 2s. Here we 6 over 6, and then here we got to have an s in the denominator, and it's basically 2s, so we've got to be 3, so that gets us 6s. And okay, so this is equivalent to that. Now what we do is say, okay, so this is equal to 1 over 3s squared Ted, plus 2s plus 6. And then we got the 6s in the numerator times 6s in the numerator. Now, what do we do with that? This is our resistance. Now we multiply that by 6. This is our R. We multiply that by 6 over S, which is our I, and this gives us our voltage. So this is the same thing as we had before, or is it? Here's S's go, so it's 6 over 3S squared plus 2S plus 6. Now, is this the same thing as we had before? We had a 12, didn't we? We had a 12 instead of a 6. Somehow I slipped a value of 2 someplace. Anyway, so someplace I messed up a little bit, but other than that, it's the same thing. This should be a 12? Huh? This should be a 36. Okay, so this should be 36. Now, why is that different from my other one? Huh? Okay, all right. So this is the same. I'm not going to go any further with this one, but this is, okay, yeah, it is the same, yeah. Oh, yeah, it is the same thing. It is exactly the same thing. So this is the same thing, yes. Okay, now, any questions about these two approaches? This isn't as bad as I thought it would be. It could be, this can get worse. But this 1/1 thing, if you would rather do it that way, it's your choice. They both come out to the same number, and from that point on, they work the same. They came out the same. So that gets you two approaches to working this question. Either one I'm comfortable with, and they come out with the same number. This one is a voltage source, 12, and find the inductor current. So this one would be one where we actually are going down in and finding some current in this device. Now, in order to find the current, if we find the volt, okay, well, we've got the voltage, and all we have to do here is basically say what? Find the inductor current. Is the voltage across each of these is the same, it's 12. So what would be the current of just across that device right there? It's no different than you would do if it was all resistors. Okay, so you don't have to worry about everything in this question. Number 25, you concentrate on just this part right here. And what is the number 25? Whoops. Okay, so with a question like this, you don't have to worry about the 6 ohms or the 0.5 farads. Your voltage across each of these devices is the same, it's 12. So in number 25, concentrate on what they're asking for, and they're only asking for the current through that one device, so we can ignore the other ones. You can ignore resistor, you can ignore capacitor, and just concentrate on the one device, okay? So in this case, you can ignore this one, you can ignore this one, and just find the voltage across that. So basically it's 12. So it's 12 over S. This is 2 Henry. So let's go and let's change to red. So the answer here is 12 over S. This would be 2S. So what is my current? I is equal to what? Voltage, 12 over S, divided by 2S. Okay? Is that right? That's it. So it's what? Well, okay, so it's 12 over, this is 2s squared, 6 over s squared, so it's equal to, now, what is that on your sheet? It's real 3. So your current is equal to what? S squared is n plus 1 is equal to 2. N is equal to 1. So it's equal to 6t. That's my answer. What does it look like? It's a ramping function. 6t is a ramping function. That's all it is. Okay? Do you ever use ramping functions? Yes, you do. For ramping waveforms, for things that go slow, that gradually go higher in temperature or whatever, if you're gonna do ramping of temperature, you would use a t function for that kind of thing. Okay. That's all it is. There's your answer. Some of these are easy, some of them aren't. This is an easy one, okay? So let's go get another one. That's number 25. As long as we're working through these, it's kind of fun, and everybody kind of, yeah, it's kind of, I can see that. But then I say you're going to put a test together, everybody gets real. Yeah, I like, oh my goodness, gotta have a test. Sorry, I am sorry, but you know, it's what makes you. It's whatever toughens you up. So another current one. This is another current one. Number 26 is another current one. And again, you have the same issue. And this is 5. This is 1. This is 1 farad. All right, so let's just work out with the 1/1 rule because that's what we did last time and it seemed to work out pretty well. Anybody have any problem with 1/1 rule? Hopefully not. Let's just do it. Okay, so voltage, find V of t. Okay, V of t is what? So it's equal to I times R, and this is the combined R. Okay, so 1/1 rule. 1 over, this is 5. This is 1s. This would be 1 over s. So basically it's 5, excuse me, it's 1 over 5 plus 1 over s plus 1 over 1 over s, or just s. So this is equal to what? So what is our common denominator here? 5s, right? So I have to have 5s in the denominator. So it's, what do I have to do to get the 5s? So this one I have to multiply s times s. This one I have to make 5 times 5. And this one I have to multiply what? 5s over 5s. Now I've got it. So I've got a common denominator. So you see what I did? I have to get a common denominator. It's 1 over. This is 5s squared, that's that term, plus s plus 15, right? And that's all times 5s in the numerator. So I've got 5s over 5s squared plus s plus 15. And these are not nice problems, by the way. These are not nice at all. Is this, where did I get my 15? This is, I don't think that should just be 5s squared, right? Yeah, that's not, that's a 5s squared. Okay, so it's 5s squared plus 1 this is plus s, that's the s term, plus 5, and that's all it is. Yeah, 1 times 5, Ted. That's it, 1 times 5. Okay, so that's our, that had been a lot nicer if this would have been like something other than 1, but it wasn't. It was 1. So this is what we got to go with. So plus s plus 5. So this would be, you got to get a 1 in front of that s squared. So we cancel. So this is equal to s over s squared plus s over 5 plus 1. Again, this is not necessarily nice, but it is doable. So minus b plus or minus b squared minus 4ac all over 2a. So minus b is 1/5. Minus 1/5 plus or minus square root of b squared, which is 1/5 quantity squared minus 4. Okay, so over 2. So this is over 2 as well. So you can write this as s squared plus 1/10 quantity squared plus this squared. So it is the fifth squared minus 4. Squared. 0.2 times 0.2 minus 4 is equal to that. Okay, 99 over 25. 0.96 minus 3.96. 0.98. So plus or minus 0.99i. So it would be 1.98. Okay, so 0.99. Okay, so basically the answer here is s squared plus s, not squared, Ted, it's s plus 1/10 quantity squared plus 0.99 squared. And that gives you an answer that you can then plug right in. So this is the same as the earlier one. You use rule 19 and you get your answer. And the coefficient in front of it is 1. You're all set. You're done. No, it is not, because you've got S in the numerator for this one, and that gets you rule 20. No, in this one you can't use rule 20 exactly because it's S minus A, and there is no A. Okay, so in this case, you do have to, did I do something wrong? I said, did I say 10 over S? I think that S term goes away. It's, I think the S term in the numerator goes away, so it's 10 over. Did I? Yeah, I didn't multiply this times 10 over S, and that gets that term to go away. So basically, yeah, you can use the same rule as you can use the same set of circumstances as before. Nobody's correcting me on this stuff. I'm making mistakes right and left. So it's 10 over S plus 1/10 quantity squared plus 0.99 squared, which is equal to 10 sine of 10e to the minus t over 10 sine of 0.99 t. Okay, now, can everybody work one of these? The hard part is getting from here to there using the quadratic equation. Okay, S squared plus S over 5 plus 1. Getting from there to, it's S squared plus 0.2S plus 1. Getting from there to here. Okay? So if you plug in the minus b plus minus squared b squared minus 4ac, you're going to get the you're going to get the two parts. The real part is the part that goes here. The imaginary part is the part that goes here. Everybody follow that? Real part, imaginary part. This is math. This is not electrical engineering technology. This is math. This is just a math issue. How do you get from here to S plus 1/10 quantity squared plus 0.99 squared? How do you get from here to there? Because this fits into your formula. And how do you get from there to there? Is the question. Minus b minus a fifth over 2 plus or minus the square root of b squared, 0.2 squared, minus 4ac, minus 4, that over this. And this part becomes this part, and this part becomes this part. Any questions? 0.2 squared minus 4, okay, so let's do that part. Let's all practice this because I want you to get this because this is the key to this, doing this. Okay? So everybody got to 0.2, right? Everybody from 0.2 minus b 0.2 divided by 2 is 1/10. That's easy, okay? But this part right here is not so easy. It's 0.2 squared minus 4, okay? So square root of 0.2 squared minus 4. Okay. So evaluate this part, the square root of 0.2 squared minus 4ac, or minus 4. Okay, what do you get? You take that divided by 2, 0.99. And that's your 0.99 squared, and that's this part right here. Please try that, because that's the key to getting through this mess. Once you've got to that point, all you got to do is look at Rule 19 and you're done. Okay? Everybody got that? Okay. So that gets you that. Okay, number 26 is done. It's in the books. Okay. 27. Oh my goodness. What are we doing now? Okay, so this is a current. It is a what? It's 5 delta. So you remember what you do with that 5 delta? X? What do you do with the 5 delta? This is 2 ohms. This is 1 Henry. You're going to get so tired of 1 Henry. But anyway, let's go back and let's look at this from a. Okay. So, what does the 5 delta convert to? Straight old 5. What is a 2? 2. What is a 1? It's S, 1 over S. So now they want to know, find the voltage of this guy. So this is going to be a little different, but it's pretty much the same kind of thing. So what is it? 1 over 1 over rule, or again, you can do the Norton to the Thevenin if you want to, but let's just do the 1 over 1 over rule. 1 over 2. So I'm looking for the resistance of these three. 1 over 2 plus 1 over S plus S over 1. I'm just going to say S over 1. Okay. So what is our common denominator of the denominator is equal to what? 2S, it looks like. So it's S over 2S plus 2 over 2S plus 2S squared over 2S. Everybody bite on that? You have to look at it and say, what is the common denominator? So it's 2S, 2 times S. Okay, so 2S, S over 2S plus 2 over 2S plus 2S over 2S. Okay, so there you go. So now your denominator becomes your numerator. So this is equal to what? 2s over 2s squared plus 2, excuse me, 2s squared plus s plus 2. Now that's my resistance. What is my current? 5. So just multiply by 5. So I've got 10s over what? 10s over s squared plus 2s squared plus, okay, so I've got 10s over 2s squared plus s plus 2. It's an s. Which is equal to 5s over s squared plus 0.5s plus 1. Okay, what do you have to do with this? Minus b plus 1 b squared minus 4ac all over, that's this one right here. And it's what you got to do. You got to find what that is. Now, if you find what that is, what can you do with that? This one, it's not as easy to do the rule 19 because why? In rule 19, there's a b in the numerator. In rule 20, there's an s minus a in the numerator. There is no straight s in this sheet. Okay? So now you are forced to do the k and the k squared. So this is kind of the bad side of straying off of the straight and narrow, which just use a v as a something over s. Now we've got to mess around with finding the k and the k star and all that mess. So here is where we're kind of having to now we do have to use the, so this is equal to 5s is equal to k over something plus k star over something. Okay? And this will get us that formula that we had where we have all that stuff. So let's basically we have to factor this. So it's minus b plus or minus square root of b squared minus 4ac all over 2a. All right, so b is 0.5, so minus b is minus 0.25, excuse me, over 2, plus or minus 0.25, plus or minus square root of b squared, 0.5 squared minus 4 times a times c. A is 1, c is 1, and that's all divided by 2. So it's minus 0.25 plus or minus, so now we put in there plus or minus 10. 0.5, so we say this, in our calculator, start again, square root of 0.5 quantity squared minus 4 equals square root of 15 over 2i. Quantity, okay, so it's 1.936. So this part right in here is equal to 1.936. 1.936 divided by 2 is 0.968. So it's minus 0.25 plus or minus 0.968i. All right? So this is equal to what? S plus 0.25 minus 0.968i, and this is S minus, excuse me, plus 0.25. If this is a minus, make this a plus. They got to be the opposite. Okay, this is minus, this would be plus 0.968i. All right? Now we go to war with this. We say let S equal minus 0.25 minus 0.968i. We cross multiply. 5s is equal to k times s plus 0.25 plus 0.968i plus k star times something that we know is going to go away. And then we put our s into there. We put our s into here. And what happens to this? It's 5 times 0.25 minus 0.968i is equal to k times what? This goes away and it's 2 times 0.968i. And there's our, how you find k. K is equal to, come over here, k is equal to 5 times 0.25 minus 0.968i all over 2 times 0.968i. And there's my k factor. Now, how do you find that? Get your calculator out, put it in a complex mode. So it's equal to 2, that's 5 times 0.25 minus 0.968i, parenthesis. So it's 5 times parenthesis 0.25 minus 0.968i divided by so I get k is equal to 2.419 at angle 14.48. So my final answer is what? 2 times k. So my final answer for this is the voltage of T is equal to times 2.419 e to the minus 0.5 t cosine of what? 0.968 t plus 14.48 degrees. And I'm done. Any questions about number 27? Any comments about number 27? You never want to see these again, right? They're there, okay? Well, any questions so far? Everybody sees now that you kind of are exposed to these, you got to see, okay, I get it. I don't like it, but I get it. 28, again, these aren't easy. Number 28, Shoot. I have an 8 sine of 2t. Then I have a 4. I have a 1. And I have a 0.25. All right, so tell me the steps. What are the steps here? Leo, what are the steps to solving this thing? Just give me the steps. Hmm?
You want to get it to.
Well, the last time we did it, we didn't use the Norton. I mean, you can do it if you want to. You have to decide whether you're going to use the Norton approach or whether you're going to use the. And I'm not too saddened by the 1/1 rule. If you can handle the 1/1 rule, if you can do that, you're okay with doing it the straight approach. What's the first step? Right. What is the voltage? How do you write the voltage in Laplace? Okay, I'm gonna start writing in red. So how do you start writing in red?
The current source.
Oh, okay. How do you convert this to Laplace? How do you what's the current source in what's the current source in Laplace? If I were writing this in red, what would I write over here instead of 8 sine of 2t? What would I write? How would you go about it? Rule 7. Yep, rule 7. What does rule 7 say? Con, what is it? What is it? What does rule 7 say? Okay, I forget your name. What does rule 7 say? I'm I'm picking on you because I want to get everybody kind of. I see the glaze in your eyes a little bit, and I understand it. But you're going to have to be able to do some of this stuff in order to get through this course. What is what does Rule 7 say? I'll give it to you. Rule 7 says A over S squared plus A squared is equal to sine of AT. Right? So I've got 8 sine of 2t. 8 sine of 2t. What is A? 2. All right? So now I write this out as what? 2 over what? S squared plus 2 squared. And I've got 8 in front. So it's 8 or 16 over S squared plus 4. So my voltage, my current supply up here, my current supply is that. So when I multiply that times the 1 over R rule here, I get my voltage. Everybody see that? So this is my current supply. This is my I. Everybody see that? Now, what is my R? We've done this about 3 times already today. What is my R? I'm going to take a picture of this and start over again. So I'm going to, yeah, 60. Okay, so my, here's this. It's an I. This is 4. This is 1. This is 0.25 F. Okay, so this is (16) over S squared plus 4. And this is 4. And this is S. And this is 4 over S. Now, what is the R here? It's 1 over 1 over rules. So basically it is 1 over 4 plus 1 over S plus S over 4. Now, what is the common denominator? 4S. In order to get a 4S here, I have to multiply numerator and denominator by S. For here to get a 4S, I have to multiply by 4 times 4. And over here, I have to multiply by an S. So the answer to the R is equal to 4S over S squared plus S plus what? 4, right? Isn't that right? S squared plus S plus 4. So that's my R. This is my R. This is my I. What is V? I times R. And this is my combined R. So what is V? V is equal to what? 16 over S squared plus 4 times, that's my I, times my R, which is what? 4S over S squared plus S plus 4. Oh my goodness. Now what do you do with this? What do you do with this? Anybody have any ideas? All right, it is 64S over S squared plus 4 times S squared plus S plus 4. What do you do with that? A1 over S plus 2I plus K1 star over S minus 2I plus K2 star over S plus something plus K2 star over S plus something else. Now, what is this something else? Minus B minus 1 plus or minus square root of B squared, 1 squared, minus 4AC or minus 16. Excuse me. Minus 4AC, which is A is 4 and 16, divided by 2. Okay. So what is this? It's S plus a half. What is this? Square root of 15 over 2. What is that? I'll let you figure it out. All right, but that's what that is. It's s plus a half, plus something I, it's square root of 15 over 2. What's square root of 15 over 2? Point 936. Find the answer. So this is 64s is equal to this. You let s equal 2I, let s equal, and then let s equal blah, 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 that, and you get your k, you get your k star. And it's going to equal something plus something. It's going to be equal to something cosine plus some 2t plus an angle plus something e to the minus t over 2 cosine of 1.936 t plus an angle. And there's your answer. Help. That's it. Please don't shoot. Don't shoot me yet. Okay? Any questions about how this is done? You've got to practice these. You've got to go back and you've got to practice them. You got to be a little bit, you know, in my estimation, if you took about 4 sheets of paper, and that's what I'm going to give you, you have about 4 sheets of paper. You take each of these problems and shrink them down and put them in little corners of that piece of paper and see the answers and see how they're done. Now, I'm going to change the numbers, but I'm not going to change the process. The process is the same. Okay? So it's just a matter of looking at something and being able to dissect it well and being able to do these that's your process. Now you say, why are you doing this? Well, it's because this is what this course is about. It allows you to solve all kinds of problems. It allows you also to pass the PE test. There's problems like this on the PE test. So if you want to be a PE, this is the best way, one of the best ways of getting there. And these and the 3 equations, 3 unknowns with power was that's how I got to be a PE, right here, this and that. So they aren't hard. I hate to say that, they aren't hard. They're just time consuming and a lot of steps. And that's why they put them in here, because that's what you're going to end up doing, is a lot of problems that are not necessarily hard, but it's a lot of steps. You just have to persevere. Okay? I'm going to shut down today. We are through number 28. I'm going to consider this one done. Okay? Take care. Have a good day. If you have questions at done, I've assigned you to do 2 of them. Please do those. Those are counting as quiz questions. So each day, each week, you do 2 more, and that'll probably be your assignment through the rest of this stuff, because I just want you to keep going.